Imagine a world without rain, snow, or any form of precipitation. It would be a dry and barren place. Precipitation in all its forms plays a crucial role in shaping our environment and sustaining life on Earth. Hello, I'm Ryan Kim Nuabo, and in this report, we will delve into the fascinating world of precipitation, exploring its definition, types of precipitation or its forms, factors affecting it, and its importance in our daily lives. So, what is precipitation? Precipitation refers to any form of water that falls from the atmosphere to the Earth's surface. It includes rain, snow, sleet, and hail. This natural phenomenon is an essential part of the Earth's water cycle, which involves the continuous movement of water between the land, oceans, and the atmosphere. And now let us know the importance of precipitation. Precipitation plays a vital role in our environment and everyday lives. It provides a freshwater resources for drinking, irrigation, and hydroelectric power generation. It sustains ecosystems and supports the growth of plants and the survival of animals. Precipitation also replenishes our rivers, lakes, and groundwater, maintaining the delicate balance of our planet's water cycle. Precipitation is essential for agriculture as well. Farmers rely on adequate rainfall to nourish their crops and ensure a bountiful harvest. So there are several factors contribute to the occurrences and distribution of precipitation. These include atmospheric temperature, humidity, air pressure, and the presence of the clouds. The interplay of these factors determines the type and amount of precipitation in a given area. For example, warmer temperatures tend to favor rain formation, while the colder temperatures lead to the formation of snow or sleet. Temperature affects the phase of precipitation. Warmer temperatures typically lead to rain, while colder temperatures result in snow or other frozen forms of precipitation. Humidity determines the moisture content in the air, which is essential for precipitation to occur. And air pressure and atmospheric condition contribute to the formation of clouds and the movements of air masses, influencing where and when precipitation falls. Precipitation comes in various forms, each with its unique characteristics. The first one is the rain. It is the most common type of precipitation. It occurs when liquid water droplets in the atmosphere merge and become heavy enough to fall to the ground. Rain is associated with warmer temperatures and is a crucial source of fresh water for various ecosystems and human activities. As we all know, rain can come in many ways, and one example of that is drizzle. Drizzle tends to be light and can sometimes be mist-like, reducing visibility but not accumulating significant amounts of water. And the difference between drizzles and rain is that rain is characterized by larger and more widely spaced water droplets compared to drizzle, while drizzle consists of smaller, more closely spaced water droplets than rain. Next is the snow. Snow forms when water vapor directly crystallizes into ice without passing through the liquid phase. It occurs in cold regions or at high altitudes, where temperatures are below freezing. Snowflakes are intricate ice crystals that fall and accumulate on the ground, creating a winter landscape. Next one is we have the sleet, also known as ice pellets. Forms when raindrops partially freeze before reaching the ground. This occurs when there are layers of freezing air above the surface. Sleet is often associated with transitional weather conditions when there is a mixture of warm and cold air masses. And the last one is hail. It is the type of precipitation that forms within strong thunderstorms characterized by powerful updrafts. It begins as small ice pellets that are lifted by the updrafts into the colder regions of the storm cloud. As they circulate within the cloud, they accumulate layers of ice growing in size. When the hailstone becomes too heavy for the updraft to support, they fall to the ground. Hailstones can range in size from small pellets to large stones. So before we move on to our next topic, let's just watch some clips about precipitation.
You might think that precipitation sounds like a bit of a dull subject, but we're not just talking about rain and drizzle we experience here in this country. It also includes extreme weather such as hailstorms and blizzards. In this film, we're going to be looking at those examples of extreme weather and finding out how rain, hail and snow are formed. All precipitation develops in clouds, and clouds are formed when water vapour in the atmosphere cools and condenses. As the water vapour condenses, it forms droplets, and if the cloud develops within or moves into a part of the atmosphere that is below freezing, then the droplets form ice crystals. The cooling process which first forms clouds can happen in many different ways. Air may be forced to rise along a warm front, and as it cools, deep layers of clouds can develop, sometimes reaching many thousands of metres all the way down to ground level. Air may also be forced to rise as a cold front approaches. In this instance, a wedge of cold, dense air pushes under the warm, moist air ahead of it, lifting it. Weather fronts tend to bring generally cloudy skies with relatively long spells of rain or drizzle, or sleet and snow at colder times of year. And finally, air may be forced to rise simply because it's heated by the Earth's surface and it convects. This is what we often see on a summer's day, with cumulus clouds building up and sometimes developing into towering cumulonimbus clouds. Then we can get very heavy rain and even hail. Let's look first at rain and drizzle. The only real difference between rain and drizzle is the size of the droplets. Drizzle is composed of very small droplets, 0.5 millimetre or less in diameter. The tiny droplets that fall from the cloud itself merge together or coalesce until the droplet size becomes large enough to fall from the cloud under its own weight. Even though drizzle is made up of small droplets, it can still produce some very poor weather. Heavy drizzle can seriously reduce visibility because the droplets are small and close together. In tropical climates, where deep clouds develop in warm air, this coalescing of droplets can produce quite heavy rain, but in our latitudes, anything more serious than drizzle usually starts off as ice crystals high in the atmosphere. When clouds build in air that's below freezing, we often get a mixture of ice crystals and supercooled water droplets. That is water which is just below freezing but hasn't yet turned to ice. It is this mix of ice crystals and supercooled droplets that is really the key to understanding how most precipitation forms. The ice crystals are able to grow rapidly where there is supercooled water nearby, because as soon as the supercooled water makes contact with the ice crystal, it immediately freezes. Then, as the crystals drift through the cloud, they connect with other ice crystals in a process called aggregation, and large snowflakes are formed. This process of aggregation can take place in any fairly deep cloud, whether it's formed in layers along a weather front or by the convective bubbling up process. If the air between the base of the cloud and the ground is no warmer than 2 degrees Celsius, then the snowflakes reach the ground intact. In warmer conditions, when the air beneath the cloud is above 2 degrees Celsius, then the snowflakes will melt and arrive on the ground as raindrops. This is the way in which almost all significant rain is produced in our latitudes. It starts as snow, but melts before it reaches the ground. The most energetic cloud types, and the ones that can produce really heavy rain, are driven by strong convection. As the air cools, the water vapour condenses into water droplets, forming clouds. As the cloud grows up through the atmosphere, it will soon pass the freezing level, and water droplets within the cloud will freeze and form ice crystals. That is called glaciation, and an anvil shape is typical of cumulonimbus or thunderhead clouds. The fuzzy edges of an anvil cloud show that there are ice crystals present, and the cloud has grown well beyond the freezing level. These ice crystals grow as other water droplets nearby freeze onto their surface, creating a coating of ice, and small hailstones are formed. Inside the cloud there will be rising currents of warm air, and some quite severe downdrafts of cold air. Small hailstones may fall through the cloud, helping to create the downdrafts. They can also be carried back up through the cloud by the rising currents of warm air. This can happen many times, with the hailstone melting and freezing and developing fresh coats of ice during its journey through the sub-zero part of the cloud. If you're brave enough to venture into a hailstorm, you can actually cut a hailstone in half and see how those layers of ice are built up like an onion as the hailstone travels up and down within the cloud. In really severe storms, that process is repeated so often and the currents of air are so strong that hailstones as big as golf balls can be supported. In really severe storms, hailstones as big as tennis balls have been recorded. The largest hailstone ever recorded in recent times came from Bangladesh in 1986 and measured a whopping 15 centimetres across. It weighed over a kilo. That's the same as a bag of sugar. Next time you're out in the rain, have a think about what's going on above your head and the journey those raindrops may have made from water vapour into cloud droplets, snow, maybe even hail, before falling to earth as rain. If you want to learn more about precipitation or anything to do with weather and climate, visit the Met Office website.
So there are three types of rainfall: the convectional, the orographic, and the cyclonic or frontal precipitation. So the first one that I will discuss to you is the convectional precipitation. Convectional precipitation occurs when warm air rises due to localized heating of the Earth's surface. As the air rises, it cools adiabatically, leading to condensation and the formation of cumulus clouds. These clouds can develop into towering cumulonimbus clouds, which produce heavy showers, thunderstorms, and sometimes hail. Next is the orographic precipitation. Orographic precipitation happens when an air mass encounters a topographic barrier such as a mountain range. As the air is forced to rise over the barrier, it undergoes adiabatic cooling. This cooling can result in the formation of clouds and precipitation on the windward side of the mountains. The air descends on the leeward side, creating a rain shadow effect where the area experiences less precipitation. And lastly is the cyclonic or frontal precipitation. Cyclonic or frontal precipitation occurs when a warm air mass and a cold air mass meet. The warm air mass is lifted over the denser cold air mass, leading to the formation of fronts. So there are two main types of frontal precipitation, the warm front and the cold front. In a warm front, the warm air mass gradually rises over a cold air mass. As the warm air rises and cools, it produces a large area of stratiform clouds and light to moderate precipitation over a wide region. And in a cold front, the cold air mass advances and displaces a warm air mass rapidly. The warm air is forced to rise abruptly, leading to the formation of towering cumulonimbus clouds and intense precipitation, including heavy rain, thunderstorms, and sometimes severe weather.
Rain. It's water from the sky, but not all rain is created equal. There are three types of rainfall: orographic, frontal, and convectional. Orographic precipitation, also known as relief precipitation, is most commonly found in coastal regions with a mountain range. Wind from the sea contains a lot of moisture, and when it reaches a mountain, it cannot continue and is forced upwards. As the air mass goes upwards, it cools and eventually condenses into clouds. Soon after, the cloud can no longer hold any more water, and it begins to rain. Most of the precipitation ends up on the side facing the ocean, called the windward side, while the other, or leeward side, gets little. This causes one side to be moist and full of vegetation, while the other is dry. Next, there is frontal, or cyclonic precipitation. When a warm, moist air mass meets a cold, dry one, the warm one rises, and the water vapor in the warm air condenses as it rises, forming clouds. Eventually, it will rain. If it is a warm front, then the warm air will gradually rise, causing a mild to moderate prolonged rainfall. If it is a cold front, then the warm air will rise quickly, causing unstable weather, including thunderstorms. Frontal precipitation is extremely common on the British Isles. The final type of rainfall is convectional precipitation. On hot days, the sun heats the ground. The ground then releases some of that heat, which warms the air. That warm air rises and cools to condense its water vapor into a liquid. This causes rainfall to initiate almost instantly, usually without much warning. Since convectional precipitation relies on the sun heating the ground, it is far more common in tropical regions, where the sun hits at a more direct and intense angle. These three types of rainfall have ultimately shaped our society, providing the hydration necessary for vegetation to exist. And until next time, thanks for watching.
So before we conclude, let's just answer first the question that I prepared. In conclusion, precipitation in all its forms is a fundamental force of nature that shapes our world. It nourishes the earth, supports life, and maintains the delicate balance of our ecosystems. As we face the challenges of a changing climate, studying and understanding precipitation patterns becomes increasingly important because understanding the factors influencing precipitation patterns, monitoring changes due to climate change, and managing its impacts are crucial for sustaining ecosystems, supporting agriculture, and ensuring water security. Let us all cherish and protect this invaluable resource, ensuring a sustainable future for generations to come.